Okay, so we went ahead and we multiplied and divided some rational functions. So today we are going to be adding and subtracting rational functions, or rational expressions. Okay, so the thing about these, just like when we were working with our multiplying, is that you're going to go ahead, you need to create common denominators. And you're going to do that by using your least common multiples, or of course what we call our LCD, least common denominators. And what I mean by that is when you have something like 1 over 6 plus 1 over 9, you of course are not going to make your common denominators 54 by multiplying 6 and 9. What you actually want to do is multiply this by 3 over 3 and 2 over 2, so that your new denominator is 18, so 3 over 18 plus 2 over 18, and now you can go ahead and add your numerators and reduce if need be. So exact same process for this. Of course, the only difference is that we have to figure out what our multiples are going to be. So on our first example, we're just going to start with like denominators. So we're going to start with 4x over x minus 2 minus x over x minus 2. Okay, on this one, our denominators are the same. So what we're going to do is that we're simply going to keep our denominators and subtract, because we have a subtraction problem, our numerators. So final answer, 4x minus x, that's a 3x over, keep that denominator, x minus 2. All right, pretty straightforward. Of course, at this point, I would want to check, hey, can I cancel anything out? Nope, x minus 2. There's no factor of x minus 2 on the top. All right, and our domain here is that x cannot be 2, but we know that from looking at our final answer. So we're totally done on that one, ready to move on. Now let's look at something without common denominators. So we need to go ahead and create those. So for example 2 here, we're going to start with 7 over 9x squared plus x over 3x squared plus 3x. All right, so as you can see here, of course, these denominators are totally different, meaning that we can't add them up. All right, so first thing is that you're going to go ahead, I want you to factor your denominators and not your numerators, because we're going to be combining like terms. So only your denominators are what you're going to factor. So this is now 7 over 9x squared cannot be factored because it's a monomial. The only thing we can factor here is this GCF 3x times x plus 1. All right, and if you'll notice here, we have, we have this 9x squared. Well, we have a factor of 9x squared. A factor of 9x squared is 3x. All right, so that's part of this one. But we still have this factor of x plus 1. So what we actually need to create here is that we need to create our least common denominator, and our least common denominator is going to be 9x squared times x plus 1. And the reason that's our least common denominator is because 3x is a multiple of 9x squared, but we need to create that x plus 1. So 9x squared times x plus 1. All right, so from here, we have to figure out what we need to multiply these fractions by. So this guy has the guy on the left has a 9x squared, but it's missing an x plus 1. So we're going to go ahead and we are going to multiply the one on the left by x plus 1 over x plus 1. As a reminder, if you multiply your denominator, you also have to multiply the numerator by the same thing. So when you distribute that out, we get 7x plus 7. All right, so our guy on the right has a 3x and it has an x plus 1, but it's actually missing this 9x squared here. So it's missing that part. We don't have to multiply it by 9x squared. We're just trying to get to 9x squared, meaning that we're going to go ahead and we're going to multiply this one by 3x over 3x. That's going to get us to that 9x squared. All right, so 3x times x, 3x squared. Of course, at this point I could reduce, but we don't want to reduce because we want to create those, we have to have those like denominators. All right, so now it's time to add up our numerators. I can't combine any like terms. So 3x squared plus 7x plus 7, I can only write it in standard form, over 9x squared times x plus 1, and it's totally fine to go ahead and keep that denominator in factored form. Because, and the reason that we like to keep it in factored form is that this can easily show me what my domain is. X can't be 0, x can't be -1, there's no other domains that we crossed out, so we don't have to add anything else. So let's kind of go back to these steps. So we factored our denominators, we then created our least common denominators by multiplying by our least common multiple. We then added, of course, sometimes you want to subtract numerators, and then if need be, simplify, but only if needed. And don't forget that when you simplify, you would have to state your domain. Okay, so that's a pretty basic one because we didn't have to simplify anything, but let's take a peek at a subtraction problem here. It gets a little bit more complicated because we're going to have to check to see if we can reduce. Oh, taking a peek back at this, the reason I know this can't be reduced is that 3 times 7 is 21, and there's no factors of 21 that add to 7, so this numerator can't be factored. So just a heads up on those factorings. Example 3. We're going to be working with x plus 2 over 2x minus 2 minus a negative 2x minus 1 over an x squared minus 4x plus 3. Okay, actually, before we start this one, and this is just general polynomial hint, is that I've got a minus a negative. I don't want a minus a negative. I'm going to lose a negative in there. I'm going to actually distribute my negative in there. So I'm going to turn this into an addition problem. So this is now plus a positive 2x plus 1. So just distributing that negative out there so that we get rid of any of those. All right, now it's time to go ahead. First step is to factor those denominators. So keep those numerators as they are. Not that you can factor these, but you could. If for some reason you had a factorable numerator, don't factor it. So plus, and now on our other one, we have a positive 2x plus 1, but our denominator is x, so we're going to minus 3 and x minus 1. All right, now we got to look at these factors. So we have, I like to highlight them just so that we can see what we have for both sides. We have an x minus 1. X minus 1 is in both of them. Okay, so we don't need to multiply by that. But we do have a 2, so I'm missing a 2 over here, meaning I need to multiply it by a 2. And then the next one here, oh, I already used orange, let's use green, is an x minus 3. So we're missing an x minus 3 over here. Okay, so once again, I like to write the denominator before I get started on multiplying, just so I'm very clear as to what I need to multiply by. So the new denominator needs to be 2 times x minus 1 times x minus 3 plus, once again, same denominator over here, 2 times x minus 1 times x minus 3. And again, that would get me, if I'm looking at the colors, a yellow, an orange, and a green for both. All right, so we need to multiply. Start with the left-hand side. We need some green on here. Go back, color code, just for fun. All right, so we're multiplying this guy by an x minus 3 over an x minus 3. Don't forget that your parentheses also apply to your numerator. All right, so on this one, when we multiply everything out, get an x squared, a negative 3x and positive 2x, so a minus x, and then a negative 6. All right, now on the other side, the yellow's too late, we need to multiply this by a 2 over 2. Don't forget you have parentheses here. So this top side is 4x plus 2. All right, now we can go ahead, we are in a position that we can add up our numerators. So x squared can't combine with anything. So we have x squared, x squared, a negative x plus 4x. That's going to go ahead and get us a positive 3x, and a negative 6 plus 2 is a negative 4. All right, now, in that denominator stays the same. And once again, feel free to keep this in factored form. Totally fine, because we see that our denominator there has a domain of x can't be 1 and x can't be 3. All right, I'm going to do a double check here. I have something here with is a leading coefficient of 1, so 1 times negative 4. Negative 4 factors that add to 3 are going to be a positive 4 and a negative 1, meaning that I can factor this numerator. So x plus 4 times x minus 1. Hey, you might see it already. I have 2 times x minus 1 over x minus 3. And I hope that you can see here that this x minus 1 and the x minus 1 go ahead and cancel out. Don't forget that for your domain. So x plus 4 over 2 times x minus 3, but please state that x cannot be 1. And there's our final answer for that guy. So lots of steps, but just like with multiplying or dividing fractions, keep those kind of fraction rules in the back of your head along with factoring, and you got it all the way through. Same exact steps. So there's one other topic that I want to cover on this one, and this are complex fractions. So this is also in our section 7.4, complex fractions. And complex fractions are basically just fractions in fractions. So we could have something like 5x over x plus 4 all over, so big old fraction, 1 over x plus 4 plus 2 over x. Okay, so what does this mean? As a reminder, your fraction bar means a divide. So I'm just going to go ahead, I'm going to say option 1 here is that you could go ahead and write this out. And what I mean by that is that it's a division problem. So you would have 5 over x plus 4 divided by, and then keep that numerator together, 1 over x plus 4 plus 2 over x. From here, you of course could solve, use your order of operations. You would create like denominators, then, so do everything in your parentheses first, and then go ahead, divide, flip, and multiply, and you would get a wonderful fraction. However, option 2 is a lot easier. And option 2, switch to orange, doesn't really go very well. We're going to say option 2 is that we are going to kind of fraction bust, if you've done that before, which is that we are going to multiply all terms by your least common multiple or least common denominator of all your fractions. So our least common denominator here for our denominators is that we have an x plus 4, and then we also have an x. So our least common denominator here in this situation is x plus 4 times x. All right, so we're going to multiply all of our terms by that. So this guy up here, we're going to multiply by x plus 4 times x. This guy over here, we're multiplying by x times x plus 4. I just wrote it in a different order. This guy again, x times x plus 4. Once again, same thing. Multiplication doesn't matter which order that you write it in. All right, and if you multiply everything by the same term, they go ahead, they start, it's totally fine. It's like multiplying something by the same number. Let's start talking about things that cancel out. So on this top one, we have an x plus 4 and an x plus 4. That's going to go ahead. Those are going to cancel out. We're left with a 5 times x. So on our numerator, we have a 5x. All right, let's look at our denominator. We have an x plus 4 and an x plus 4. We're simply left with x. Now on this one, the x and the x cancel out, but we do need to distribute. So we're left with plus 2x plus 8. Just need to combine some like terms. So final answer for here is 5x over 3x plus 8. All right, double check any sort of domain though. is that we know that x cannot be 0, and the reason we know that is that right here it can't be 0. The other one that it can't be is that x cannot be -4, because we know in this one it would be -4. And then of course it can't be -8/3, but we know that from our final answer there. All right, that's it for 7.4. Hopefully you're enjoying some fractions and factoring.